In the shadow of Jupiter orbits a frozen world that may hide an ocean of life. Europa looks like a silent ball of ice, scarred by mysterious fractures. These scars stretch for thousands of kilometers across the surface. This small moon orbits inside one of the most extreme environments in the solar system, the Earth. Jupiter floods Europa with intense radiation every day. Sunlight here is weak and cold, far too faint to warm the surface. The surface temperature is colder than Antarctica on its harshest day. Yet scientists believe this frozen shell hides something extraordinary. Beneath the ice lies evidence of a vast liquid ocean. This ocean may contain more water than all of Earth's seas combined. An entire global ocean could be hidden under tens of kilometers of ice. Jupiter's gravity constantly pulls and releases Europa. This tidal flexing creates heat deep inside the moon. The heat prevents the subsurface ocean from freezing solid. Stress from this movement fractures the surface over and over again. Salty materials from below may seep upward through these fractures. These reddish streaks could be chemical fingerprints from the hidden ocean. Some observations suggest water may even spray into space as plumes. A spacecraft could sample ocean material without ever drilling through the ice. Far below, the ocean may touch a rocky seafloor. Hydrothermal vents could provide chemical energy. On Earth, similar vents support entire ecosystems without sunlight. Microbes could thrive in these energy-rich environments. More complex life is possible, but remains purely hypothetical. Everything we imagine must first pass the test of evidence. Earlier missions first hinted at a salty ocean beneath the crust. Magnetic measurements suggested a conductive liquid layer below. Future missions will use radar to look through the ice shell. NASA's Europa Clipper mission is designed to study this world in detail. The spacecraft will perform dozens of close flybys. Its instruments will map the surface and analyze the chemistry. Thermal sensors may reveal warmer spots where the ice is thinner. Cameras will search for signs of recent activity on the surface. Spectrometers can identify salts and organic compounds. If plumes are active, the spacecraft may fly directly through them. One major question is how thick the ice shell really is. Thinner regions could be windows into the ocean below. A future lander could one day analyze surface materials directly. Reaching the ocean itself would require advanced drilling technology. A robotic submarine could explore the hidden sea. Its lights would reveal a world never seen before. The seafloor may be shaped by tectonic and volcanic forces. chemical gradients here could power life forms unlike any on Earth. Even a single microbe would change our understanding of life in the universe. Life on Earth began in the ocean billions of years ago. Europa may offer a second example of how life can begin. This small moon could answer one of humanity's biggest questions. Are we alone, or is life a common outcome of cosmic chemistry? The search for life may begin beneath a frozen crust far from the sun. Somewhere under this ice, an unseen ocean waits to be explored. Beneath kilometers of ice, the European Ocean moves in total darkness. Tiny particles may drift like underwater snow through this alien sea. Currents could circulate nutrients from the seafloor to the upper layers. The bottom of the ice shell may look like a frozen cave ceiling. A robotic explorer would map this ceiling of ice from below. Minerals trapped in the ice might slowly feed the ocean beneath. Far below, hydrothermal systems may warm the surrounding water. These vents could create chemical gradients rich in usable energy. Microbial ecosystems might gather where chemistry and heat meet. Most of this ocean would remain dark and unexplored. The surface fractures hint at constant exchange between ocean and crust. Europa's icy shell may slowly shift like drifting tectonic plates. Some regions look like broken ice rafts frozen back together. These landscapes suggest warm ice rising from below. Pockets of liquid water might exist inside the ice itself. Such eruptions would send ocean material far above the moon. Frozen droplets may fall back as fresh frost across the plains. Jupiter's reflected light gives Europa a ghostly glow. From the surface, Jupiter would loom enormous overhead. Radiation constantly alters the chemistry of the upper ice. This radiation may create oxidants that sink into the ocean. These chemicals could provide additional energy for life below. Europa may have a full chemical cycle linking surface and seafloor. All of this happens on a world smaller than Earth's moon. Yet Europa may hold twice as much water as Earth. Most of that water is hidden under an icy lid. Radar instruments can measure the depth and structure of the ice. These measurements help scientists map the hidden shell. The Europa Clipper spacecraft will make repeated close passes. Each flyby gathers clues about ocean depth and chemistry. Detailed images will reveal features as small as a house. Warm areas might point to recent or current activity. Chemical signatures may reveal salts from the ocean below. Careful navigation is needed to survive Jupiter's radiation. Special shielding protects the instruments from damage. Every bit of data travels hundreds of millions of kilometers home. Researchers will study these maps for years. Each fracture tells a story about the hidden ocean. A future mission could attempt a landing on the icy surface. Instruments could sample surface ice for ocean material. One day, a probe might melt its way toward the ocean. The journey through the ice would take months or years. Then, for the first time, a human machine would enter an alien sea. Even empty water would be a historic discovery. Finding even simple cells would change biology forever. This distant moon may hold answers to ancient questions. Worlds of water may be common across the galaxy. Beneath silent ice, an unseen ocean continues to move. Europa waits as humanity prepares to explore its hidden depths. The deeper we go, the more this ocean feels like a world of its own. Distance underwater is hard to judge in endless darkness. The icy roof may be tens of kilometers overhead. Below lies an ocean deeper than any on Earth. Sensors continuously analyze the chemistry of the surrounding water. Variations in salt and temperature reveal hidden currents. These currents could distribute nutrients across the ocean. Navigation in this environment would be slow and cautious. A faint light may signal activity near the seafloor. Hydrothermal vents could form the energetic heart of this ocean. Superheated water carries dissolved minerals into the sea. As the water cools, minerals fall like dark snow. Chemical energy here could sustain microscopic life. Even simple cell division would prove life can begin twice in one solar system. More complex organisms are possible, but remain purely speculative. The seafloor itself may be shaped by tectonic forces. Fractures could channel heat from Europa's interior. These plumes may spread nutrients far from their source. Beyond the lights lies a vast, unexplored abyss. The journey upward would be just as long and silent. Ice crystals may drift where warm and cold layers meet. The underside of the ice may be sculpted by melting and refreezing. Frozen formations could hang like stalactites in a cave. Some pockets may isolate water from the main ocean. Minerals frozen into the ice record past interactions with the ocean. Warm fractures could mark pathways between ocean and surface. Plumes would offer a shortcut for studying the ocean below. Instruments could capture tiny frozen droplets for analysis. Inside those droplets might be organic molecules. Complex chemistry is one step toward biology. Europa today may resemble Earth billions of years ago. Life on Earth began in dark oceans rich in chemistry. Similar conditions could exist right now beneath Europa's ice. This small moon challenges our idea of where life can exist. If life can form here, it may form on countless icy worlds. Oceans beneath ice could be common across the galaxy. Yet Europa remains our closest ocean beyond Earth. The answers may begin arriving within our lifetimes. Each signal brings us closer to understanding this hidden sea. Teams across the world prepare to interpret the discoveries. A single confirmed organism would change science forever. The discovery would echo across every culture on Earth. Humanity would look at the sky differently from that moment on. Two ocean worlds in one solar system would not be a coincidence. Even if no life is found, Europa will still reshape planetary science. Every crack in the ice is a clue waiting to be read. Beneath the surface lies one of the greatest frontiers of exploration. A silent ocean circles Jupiter, hidden yet real. And somewhere in that darkness, nature may have written a second story of life. Exploration often begins in silence before discovery changes everything. A subtle chemical imbalance could hint at biological activity. Repeated signals would force scientists to ask new questions. Tiny moving structures might appear in the beam of light. Structures resembling cells would demand careful verification. The data would travel across space toward waiting scientists. Teams would analyze every measurement with extreme caution. Models might suggest unfamiliar but organized biological patterns. Confirmation would be checked by independent groups around the world. News of possible life beyond Earth would spread instantly. Humanity would share a moment of collective wonder. Billions might look up at Jupiter with new meaning. Even the simplest organism would prove life is not unique to Earth. Two separate origins of life would reshape biology forever. The chemistry of life elsewhere might be similar or completely different. A new generation would grow up knowing we are not alone. Discovery would inspire even more ambitious exploration. Other ocean worlds would become high-priority destinations. Many moons may hide oceans beneath frozen shells. Europa would remain the place where the first evidence was found. Down in the ocean, the ecosystem would continue, unaware of distant observers. Life here would follow its own rhythm, shaped by chemistry and heat. Some organisms might produce faint light in the darkness. Most of this world would remain unexplored for generations. Above the ocean, the ice shell slowly shifts over time. The surface records the hidden motion of the sea below. Layer by layer, we would map this concealed ocean world. Some regions might prove easier to explore in the future. New missions could one day return with better tools. Swarms of small robots might explore vast distances. Together, they could build the first map of an alien ocean. Models would reveal how heat and chemistry circulate globally. Lessons from Europa would guide the search beyond our solar system. Similar ocean worlds may orbit distant stars. But Europa is where humanity first reached another ocean. Two ocean worlds linked by curiosity across the void. The discovery would inspire dreamers for centuries. A frozen moon would become a symbol of possibility. Beneath the ice, the ocean would continue its silent motion. Heat from within keeps this hidden sea alive. Above, the frozen shell shields the ocean from space. Thin beams of light mark the boundary between worlds. On the surface, everything appears still and lifeless. Yet below, an ocean world may be thriving. This small moon holds one of the greatest mysteries in planetary science. Checklist. It reminds us how diverse and dynamic our solar system truly is. That from far away, these worlds are only tiny points of light. Around other stars, many more oceans may wait in darkness. Europa stands as a promise that discovery is never finished. Beneath its ice, a hidden ocean invites us to keep exploring. Some discoveries change knowledge, others change perspective. Europa may do both at once. A silent surface hides an active ocean world. Every crack is a doorway to the unknown. Technology allows us to see beyond what eyes can reach. Information slowly transforms mystery into understanding. Exploration is driven by patience as much as imagination. Machines extend our senses into hostile environments. Through them, we may one day see an ocean never touched by sunlight. Whether life exists there remains an open question. Energy flows through this ocean from the inside out. Chemistry builds complexity step by step. Somewhere in the universe, such chemistry may cross into biology. Life on Earth began in water, shaped by similar forces. Two oceans, separated by space, yet linked by possibility. Above Europa, Jupiter dominates the sky like a constant guardian. Its gravity and radiation shape the Moon's evolution. Tidal forces keep the hidden ocean from freezing solid. Tidal forces keep the hidden ocean from freezing solid. Occasionally, the ocean may announce itself with a plume. Such moments allow us to sample an ocean from afar. Each grain of ice may carry a chemical story. Complex molecules would hint at deeper processes below. Discovery is a global effort that crosses borders. The question of life beyond Earth belongs to everyone. Curiosity begins with imagination. Each mission carries the dreams of generations. The journey outward is long, but filled with purpose. Arrival at Jupiter marks entry into a system of ocean worlds. Among them, Europa stands out as a prime destination. Its surface tells a story of motion and hidden warmth. Beneath that crust lies a global sea, waiting in darkness. One day our machines may glide through these waters. They will search for chemistry that edges toward life. Even the faintest sign would echo across history. Discovering life elsewhere would change how we see our own world. Our planet would no longer be the only known cradle of life. Two distant oceans linked by the same cosmic processes, and perhaps many more oceans among the stars. This small moon reminds us how much remains unknown. Mystery often hides beneath the most unwelcoming surfaces. From ice crust to rocky core, Europa is a layered world of motion. Exploration is a journey from darkness toward understanding. Together, they form one of the most fascinating systems in our sky. Our solar system is more diverse than we once imagined. And the galaxy may hold countless hidden oceans. Europa stands as a symbol of questions not yet answered. Beneath its frozen shell, an ocean continues to move in silence. The search for life leads us farther, yet also closer to ourselves. Somewhere beneath the ice of Europa, an unseen ocean invites humanity to explore.